So in this video, I'm going to derive a cubic polynomial expression for the compressibility factor from the generic cubic equation state. And that is this equation right here. So I'm going to start this by copying down the cubic equation state. P equals RT over V minus B minus A over V plus epsilon B times V plus sigma B. Now we want to get this in terms of the compressibility factor. So I'm going to divide both sides by RT and multiply both sides by V. So you will get PV over RT equals V over V minus B minus AV over RT V plus epsilon B V plus sigma B. And then now this is equal to the compressibility factor Z, PV over RT equals Z. And then now I'm going to divide both sides, the numerator and the denominator of this, by V. So 1 over 1 minus B over V minus A over RT VRT 1 plus epsilon B over V, and then 1 plus sigma B over V. So we know that Z equals PV over RT, and that also means that V will be equal to RTV over P. RTZ, over P. And now we can plug that in for all the V's in this equation. So we're going to have Z equals, and it'll be 1 over 1 minus, and plugging in V for this, so it'll be BP over RTZ, and then minus, we're going to have, this V is going to equal this, so we're going to have AP over R squared T squared, and we will still have Z. And then we need to plug it in for these as well, so all that will be over 1 plus, and we're plugging in this for V right here as well. So it will be epsilon BP over RT Z. And then the same thing for this. So 1 plus sigma B P over R T Z. So now to simplify this anymore, we can use the values of beta and Q, which beta is defined as B P over RT. And then Q is defined as A over B R T. So to plug in beta, we can plug it in first right here for this BP over RT. So we'll get Z equals 1 over 1 minus beta over Z. And then now for this, we can plug in Q for this A over RT. So we will get Q and then we can also plug in beta for the other P over RT. So we get Q beta over, and we still have the Z from here. So Z and then we can plug in beta into each of these as well. So 1 plus epsilon beta over Z, and then 1 plus beta over Z as well. So the next step to solving this will be to multiply everything by 1 over Z. So 1 over Z times Z is just 1. And then for this second set right here, you're multiplying this all by 1 over Z, and this by 1 over Z. So this will go to 1 over 1 minus 1 over Z minus beta minus, and this will be Q B over Z plus epsilon beta and z plus sigma beta. And then now all we have to do is get a common denominator between this whole thing. So to get this common denominator, we're going to multiply everything by z minus b and these two. So the left side of the equation will end up being z minus beta z squared plus epsilon plus sigma, and then that times beta z, and then epsilon sigma beta squared. Sigma beta squared. So that will be the left side, and then the right side will be if it will just be z squared plus epsilon plus sigma beta z plus epsilon sigma beta squared. That value again because of the 1 over here. So that value, and then minus our q beta times our z minus beta. So now all that's left to do is to multiply this out and combine like terms. So to make this simpler, I'm going to just do this systematically. So I'm going to just find the quantities that have z to the third, z squared, z, and then our constants. And I'm just going to list them in columns. So first we have z to the third, and then our z squared values. So our first one will just be negative b z squared beta z squared. So actually I don't even need to write the z squared here. It's just going to be negative beta. And then also we're going to have another z value when we multiply this out. So it'll be, for z, it'll be epsilon sigma beta squared. And then we'll have a constant of negative epsilon sigma beta to the third. And then our next z squared value will come from multiplying this out. So we will get, just, if we move this to the other side, we're going to want to move it all to the left side. So we'll just get negative 1. Negative 1 there. And then for our next z, we're going to get that by multiplying this out. And we will get negative b beta squared epsilon plus sigma. Epsilon plus sigma. From multiplying this out. And then we'll get another z squared from this value of epsilon plus sigma beta z squared. And then we'll get another just constant from this side of negative epsilon sigma beta squared this time from here. And then we get the single z from the side as well. So negative epsilon plus sigma beta and then finally we just have the values from here, which will be a positive q beta z, and then we'll find that a negative q beta squared. So now we have a cubic polynomial expression in terms of the compressibility factor from the generic cubic equation of state.